Some mentioned numerical method available for bracketing method, like bisection method, regular force method. Again, also for those nonlinear equation solvers, open method, Newton method, or Newton's eruption method, second method, fixed point iteration method, roots of polynomial. The third method in order to solve nonlinear equation solvers we call graphical method. So all are, don't forget, all the given methods are all iterative. The another one is linear equation solvers. It is obvious that system of using numerical solution of system of equation like Gaussian elimination, Gaussian Jordan, inverse method, LU decomposition, again also Cholesky factorization like roots and dollar type. So let us see graphical method field. So this graphical method is from the above three methods. Graphical method is most of time not very practical, but can be used to obtain a rough estimates for roots. We are expected to use initial guesses for numerical methods here. So this is the structure of graphical method is available for some points at x, y graph is given like this. Another one is bracketing method. So this is using MATLAB plot in order to solve using MATLAB program. For example, this function is available f at x, which is equals to cos into 10x plus sin 3x. This graph become available. Another one is bracketing method. Are you hearing me?
Yes, yes, yes.
Okay, bracketing method is 2-point method for finding roots. Those bracketing method, as I told above, bisection method and irregular false or false position method. So one of target of bracketing method is from nonlinear equation solvers. We are expected to guess two initial guesses. Again, also how to find endpoints of this graph is given as follow. Again, also some algorithms for each of bracketing method is given. So let us see those bracketing methods. So this is the characters of grapheting method. For example, first one is f at x graph of function no root. Second one single root, two root. If it becomes three root, multiple root. Again also the function becomes discontinuity. So this is what based on bracketing method or two half interval method. So the first one bracketing method from nonlinear equation solvers we call bisection method or interval half method. So this bisection method, most of the time we are applying one of theorem we call intermediate value theorem. Why intermediate value theorem is in order to simplify these iterative methods using two intervals. Why? Because the theorem states that if a function f at x continues on two interval, there is also two function in opposite sign. There is two interval is available. So which interval intermediate value theorem is helps in order to solve this definition of bisection method. So this is algorithms. This is algorithm for bisection method. First of all, we are picking two value and directly we can apply this f at x1 and f at xu. Step 2 again also algorithm of step 2 estimating the given roots by half, adding both the given function roots then dividing by half interval. Step 3 also, this is if it becomes lower subinterval or upper subinterval, we are going to the next steps. This is the algorithm of procedures how to use. So lastly, we are comparing the exact value with approximate value or error accuracy of this error function, or how we stop iteration for this one, for this bisection method iteration becomes this one. So this says how can iteration will take using bisection method. Using bisection method, how iteration becomes stop. So first of all, already the given exact and approximate value is given. So we are taking k value. K is the iteration or the area of iteration repeating k times. So this is the formula for bisection method. So what about advantage and disadvantage of this method is also available here. Advantage is guaranteed to converge. Disadvantage is it becomes convergence when we compare with other methods. Bisection method is so much slow. So here is, for example, how many iterations we will do in order to acquire 10 raised to minus in the solution k value. If approximating the exact value becomes 2, our iteration becomes 15. So we are expected directly substituting in the above formula. So this is handy calculation also using bisection method. So iteration 1 up to 6 is already available. First x value and two intervals, intermediate value is given already. Lastly, the last one again also error convergence is available. So this is the procedures using handling. So numerical methods advise us in order to use handy calculation or analytical more in order to advance by using MATLAB program. This is open method. The above one is bracketing method. This open method is second method, Newton method, fixed iteration point method. So what about the behavior of open method compared with bracketed method? This is generally starting from single value. We are assigning. Why? Because there is no guaranteed in order to convergence any function. So this method is either converge or diverge. This is the behavior. So Newton method we call open method from solving nonlinear equations. So what does means Newton method or how we apply numerically this Newton method using initially guessing some root of the function. So some algorithm is like bisection method available for this one also. So first of all, in order to drive Newton method, first of all, we are directly using or applying Taylor series method. This is the graph is already available here. The graph is already given. Interpreting the slope of or the seconds of these two slope of the given function directly applying using Taylor series expansion. So the general formula for this Newton-Raphel method is available here. Or this is another procedures how Newton method becomes available. Another one is again also in order to converge or what about the area of this Newton method is formula is already available here. So this is algorithm also like bisection method algorithm. First of all, we are starting some points and some intersection points, examine those points. After that, repeating the iteration. This is the procedures. This method is most of the time, most of a reference book and most of mathematicians stated that so much converge compared to other methods, so much fast. So this is one of illustrative examples in order to use Newton's eruption formula or Newton method. The another one is open method we call second method. Second method is similar to Newton's eruption method. So the main disadvantage of this method is the main disadvantage of Newton's eruption method is that the method requires determination of derivative of function several times. Here what? Newton's eruption method requires determination of derivative of function several times, but second method becomes closed sum variation or in order to draw back of this Newton method, preferable or we are removing the drawbacks from Newton method, determination of derivative of function several times. We are selecting Newton method. So the procedure is here is what analytical and numerically using backward Newton difference methods. First of all, already Newton-Raphson method given, it becomes second method. How? The derivative of determination of derivative function directly substituting using Taylor series method, we got second method. So applying for second method, Newton method. So this is the result for Newton method. I mean second method. So this is the graphical character of second method. Here is also some algorithm is available, like bisection and Newton's method. And also, what about advantage, disadvantage of second method? So here is also illustrative example for bisection method, Newton method, second method. For three method, in order to compare, one common example is available, x cubed minus 3x plus 1 as the interval of 0 and 1. So which one is slowly converge? Which one is quickly converge? So using hand calculation or using MATLAB program, we are running some results like this one. So this is the last results in order to compare three methods. First one is, this one is bisection method. Iteration in bisection method is 16 iteration. In Newton method again also iteration is third iteration, the results of Newton method. The results of second method also fifth iteration. So we are assumed that which method becomes fast converge or quickly converge already available here idea. So generally using previous example, Newton method is fastest to converge. So the three method is what about advantage, disadvantage, compare and contrast one to another is available here already. For example, bisection easy and reliable one, but disadvantage is slow. Newton is fast, but disadvantage may diverge graphically. Second is fast, but may diverge disadvantage. So this is again also comparison of bisection method, graphical fixed method or fixed iteration method and second method. So here is three method is available. What about the given equation is, can you see equation f at x which is equals to x power of e power of exponential function e power of x minus 1 for Newton method, f at x which is equals to x e power of x minus 1 for false position, and also common function is already available. This is the way of using what I'm running this function using Microsoft Excel. So from the given this function, Newton method iteration or iteration becomes fifth iteration. For regular false or false position method, 15 iteration. Bisection method also 23. So this is the difference between which one becomes for the given common or the same function, which one becomes fast iteration quickly. The another one is numerical solution on linear equation and its application. As in preliminary parties already discussed, here is also numerical method for solving system of linear equation. We are dividing direct method and iterative or indirect method. Those direct method classification of methods, like for example, for the sake of time, here is I'm solving only Gaussian elimination and LU decomposition. Some special matrix and ordering structures available here. Also, iterative method is like basic stationary, non-stationary method, Gaussian, Jordan, and Gaussian series method available. So this is the general definition for system of linear equation, numerical solution of system of equation. This is general definition. So based on this general definition, we are solving most of direct or indirect or iterative methods. So Gaussian elimination, popular technique solving linear algebra, it reduces coefficient matrix into upper or lower one. What about matrix inversion? Already two matrix is given in order to equivalent the inverses by number of such matrix. So using review numerical methods to find solution for system of linear equation, Gaussian and matrix inverse. But difficulty when we apply Gaussian elimination method in matrix inversion, there is some difficulty happen, especially when we solve hand calculation. Most of time, it is difficulties happen. That means size of matrix very large. To reduce it, it takes many time, consume time, a lot of time. So for these matters, we are expected to use mathematical softwares. Again, also, here is let us compare LU decomposition, lower and upper triangular decomposition, and also Jacobian. LU decomposition is from direct method, Jacobian method again also from indirect or iterative method. So one common system of simultaneous equations, 3 by 3 matrix size is given. So as the table is already obvious, which one becomes iteration becomes what's the difference between solution of both the given function is already given here. Okay, are you hearing my voice?
Yes,
Hello?
Vista.
Okay, okay. Let us see some application solution of system of equation. So numerically, these general topics in numerical linear algebra is given. Selected topics in numerical linear algebra. For the sake of time, this seminar focuses PCA or principal component analysis, matrix eigenvalue problem, singular value decomposition, CDO inverses, all are what application for system of linear equation. Let us see PCA or principal component analysis for what? For face detection and face recognition. So this algorithm is basically used for learning of sample or training face of images because before starting face detection and recognition, we have to require set of eigenvalue and eigenvector of sample, some trained or some sample of people's available images. So this principal component analysis is most of time used for face recognition. Again, also we can apply it on the group of color images. So this is principal algorithm. Okay, before that, okay, here is basically text images, and we are expected to calculate face vector and also face vectors and calculate the covariance matrix for all input sample images for finding the eigenvalue, eigenvector of covariance matrix. So let us see some figures. Here is detection versus recognition. So we are focusing face recognition, why we use face recognition, how we apply face recognition also. So in order to understand two persons face recognition using PCA or principal component analysis. So this is digital photography. For example, two-person series available recurring face recognition here, and also setting some data or databases each of people's. After that, already this face recognition is saved using some digital photography or album organization is available. So, for example, face expression like happiness, disgust, surprise, such kinds of face recognition is available. So, what about our key idea? Our key idea is what? Compress them. We compress low-dimensional subspace that captures key appearance characteristics of visual degree of freedoms. So, using principal component analysis in order to estimate this subspace or in order to estimate dimensionality reduction, you compare two faces by projecting the images into subspace and measuring Euclidean distance between or using Euclidean algorithm. So how eigenface is here also? Eigenface key idea was assume the most image lie on low dimensional subspace determined by the first K. K is what? Maximum variance. If these all the face image becomes small and small, so our direction of maximum variance of this one. So principal component analysis to determine the vectors or eigenfaces that span that subspaces. So we represent all face image in data set as linear combination of eigenface. So what is face recognition means, first of all? A system are computer-based security system that are able to automatically detect and identify human face. Face recognition deals with unique facial characteristics of human beings. It involves the techniques of image processing, computer vision, and pattern recognition. So, in order to simplify this face recognition, we are expected to use biometric technology. Biometric technology means like wrist recognition, fingerprint, and geometry. So this face recognition mainly includes feature extraction, data reduction, recognition, or classification. Using feature extraction is found the most descriptive feature of the face, making them to be easily distinguished from the other faces. Why face recognition we use? It is a biometric technology, as stated above, fingerprint and geometry. It is a biometric technology with a wide range of applications such as security system, credit card verification using ATM machine, preventing voter fraud, criminal identification, human computer interaction, and others. Face recognition over the biometric means, for example, it requires no physical interaction on the behavior of users. It does not require experts to interpret the comparison. So, again, also, in order to identify terrorists in the bus airport. So, for this matter, what about advantage or how the benefit is from face recognition? So, emerging fields that can be benefit from face recognition technology, such as prevention of identity theft, military base, airport, forensic, hospital, hotel, higher institution, many areas it is used face recognition fields. We can apply this application. So what about what advantage of this PC algorithm? So feature-based face recognition method. The advantage of this approach over the face recognition system is it is simplicity, speed, and intensity, small or gradual change on the face. So this PCA is, as I told above, using numerical solution or system of numerical solutions. It is a mathematical procedure that prefers dimensionality reduction by extracting the principal component of multidimensional data. So the greatest variance of any projection of data lies in the first coordinate. So this PCA's algorithm is reduced by this person appearance-based method. So let us see here algorithm of first step of this one is here is many candidates available, many candidates or some statistical image size of the trainers, those 8 trainers available. So I which is equal to the matrix system of this function I11 up to I1n, I11 up to I1n. This is system of matrix. First algorithm is what? We are assigning or obtaining a core m number of training images here. Second step or algorithm 2 is converting all image of size n by n into vector of the form this one n squared by 1. Reduction of the trainers in the matrix of the system n squared time by 1. So here is what one of target ideas or basic ideas how we treat each image as a vector in high dimensional space. So 8 trainers is available here. From 8 trainers, how we can a reduction of dimensionality of the space using eigenspace. We can apply PCA or principal component analysis or eigenface algorithm here. So step 3 again also building matrix of trainers image in dimension of this tau which is equal to n square time n square time by n of matrix system available here also already given. Step 4 we compute average phase here also we compute average phase. So average phase of this function becomes compute average phase of this function becomes m of r which is equal to 1 over m into the given matrix of this function, the above 8 trainers. M means number of trainers 8. So this is what covariance or average phase of the all given trainers. Step 5 also, then we subtract mean phase from each trainers. For example, from 8 trainers, in order to find one trainers, this is the matrix of eigenphase of covariance of individuals is available or obtained in this way. Then we what? Then we subtract mean phase from the trailing phase. Mean phase from the trailing phase, subtracting the mean phase using covariance matrix formula and step 6, which is equal to covariance matrix 1 over m. M means number of trainers. Summation I from 1 up to m yi time yi of transpose, which becomes eigenvalue or eigenspace of this function becomes a time a transpose into n square by n square or the given function above. So step 7 also compute eigenvectors for this one. Eigenvector of the above covariance is directly large number of trainers is given. How we compute eigenvalue or eigen faces of those all trainers. Step 8 considering the matrix in this form. Step 9 compute the eigenvector of this one using the above formula. So this is continuing in order to compute these eigenfaces using and this formula. Again also A time A transpose and A transpose time A are the same eigenvalue and also their eigenvectors are related by this formula U of I which is equal to matrix of A time eigenvectors of Vi. So step 10, the last one again also. Project of all training and test phase on eigenphase space. Each phase is linear combination of principal component or eigenphase. Formula Ri, which is equal to U transport time I Yi. R which is equal to all the given vectors R1 up to Rm. So how we test the image also? Step 12. In similar procedures, we are expected to do all steps for test images. While using here is we can apply what in eigenface or PCA, computing the distance in the face in each of the faces using Euclidean distance or the distance in the faces using the following formula. Here is formula for Euclidean distance. Euclidean distance between training face image and test face image. So this is formula the minimum distance indicated to class which test of image G of or this is metric space or the distance function of d of AB, which is equal to square root of summation I from n norm of AI minus BI square. So what's the problems with eigenface recognition? There is what? Let us see. Here is some figure is available. I mean some figure is available. For example, like this, such kinds of character or such kinds of facial images happen. It is difficult in order to differentiate or in order to recognize. Why? Because challenging include variation in illumination condition, poses, facial expression, aging, discretes such as moisture, breed, glass, or cosmetics. So this application is one of the advantages face recognition. So what about limitations? PCA projection is optimal for reconstruction from low dimensionality basis, but may not be optimal for discrimination. Some shortcomings become happen. For example, it requires carefully controlled data always centered in a frame size, in frame, or same sizes happen. Some sensitive to angle. Again, also, meta is complete knowledge free here is again also. Doesn't we don't know face rapid, for example, in 3D objects like some limitation is happen. So, as a conclusion of this seminar, as the first phase, numerical solution of nonlinear equation using all numerical solvers, nonlinear equation, bisection method, Newton method, secant method, regular force method. Again, also we are applying some numerical methods which are not solved analytically or difficult ones. Again, also the last one is what? As a demonstration part or implementation of face recognition using eigenface algorithm using MATLAB. So, so this is the reference is how I collect many materials for this seminar idea. Thank you. Is there any question or suggestion? You're welcome. Is there any question, suggestion?
Yes, Desta,
Yes.
how to find out the number of iterations in second method
Number of
or Newton-Raphson method?
Newton's eruption
Number of
method. Newton eruption method.
number of number of iteration in Newton-Raphson or its second method?
No, Newton's eruption method or Newton's method. You call either Newton method or Newton's eruption method. It is open
Newton-Raphson.
method. Yeah, Newton eruption method.
Yes.
Or it is called Newton method. So in order to find number of Newton's
Number of
eruption
iteration.
method or yeah, using guessing some initial guesses of the given intervals. First of all, we are guessing some initial. Again, also, what about stopping criteria for this Newton's eruption or Newton method is? First of all, in order to stopping iteration of this Newton's eruption method,
Yes, but suppose we fix the stopping criteria, then how to find the number of iteration for that?
for this PCA or for Newton method.
Newton-Raphson and second method.
Okay, in order to find iteration of this one is using error formula. That means, as I told in the previous one, error formula, either using a relative error or absolute error, using the exact value of the given function, subtracting the approximate one. If the given using during absolute or a relative error, is it the given error tolerance is given? It is
Can you write somewhere? It will better.
yeah. First of all, error tolerance is available. We are comparing the given error tolerance of this function either with a relative error or absolute error, comparing that one. So iteration, the formula for this one is using absolute error or a relative error formula for iteration of Newton method. You got me, Sandip?
No.
So stopping criteria or number of iteration method is using absolute error or true error or a relative error. Why? We know that tolerance of error is available in order to compute all the given function, derivating the given function. After that, directly substituting, comparing the given original function with approximate one. Is there any question? Aushman.
No, this sir.
Okay. Sachin. So let us stop here.
Okay. If anyone don't have question, then
Is there any question? No question? Saurabh Bansal.
No, no question, no question.
Okay, okay,
Deepak
okay.
and Abhijit.
Okay, thank you for your attention and attendance. Thank you so much.
Thanks, Deshta.
Okay, thank you. Okay, bye, bye.
Bye.